Okay, I've just moved onto this blank document here for question 1.3 because it's going to be a bit longer, but anyway. Okay, 1.3.1, simplify the following completely. Okay, so how are we going to do that there? Well, from the looks of it, looks like we're just going to have to multiply these two brackets by each other. So let's start there. 2y plus 3 multiplied by 7y squared minus 6y minus 8. Okay, so how do we multiply a binomial by a trinomial? Okay, so the way to do that is to start with, let's say we start with 2y. So we start with that term. We first multiply it by the first term there, then the second, then the third, and then we're done with that term. Okay, and then we move on to the second term now. So we take this plus 3, and then we do the exact same thing. So we multiply it by each term of the trinomial. Okay, so let's start with that. Let's say 2y times 7y squared, and I'm just going to show every step, but you don't have to actually do this. You could just write the final answer, but anyway, and then plus 2y times minus 6y plus 2y times minus 8. Okay, so that's the 2y taken care of. So there's it there. You can see we multiplied it by each term in that one, in the trinomial. And then now we can multiply plus 3 by everything. So plus 3 times 7y squared plus 3 times minus 6y plus 3 times minus 8. Okay, and just to show you, there's the plus 3's again. Okay, so now we'll just simplify that there. So 2y times 7y squared is of course 14y cubed minus 12y squared minus 16y plus 21y squared. I'm just multiplying all of these together. So then minus 18y and minus 24. Okay. And then now we just group like terms and add or subtract. Okay, so what do I mean by a like term? I mean that they have the same variable. So if you look here, we have y cubed. Okay, let's see if we have any other y cubes. We don't. Okay, so that means we can just write 14y cubed. Okay, let's move on to y squared. Aha, look, we have that as well. So we'll add those two together. So minus 12 plus 21, and it gives us 9. Okay, so you can see we just took those two because they were like terms. They had the same variable, this y squared, and then we added them together. Okay, so now let's move on to y. So here we have minus 16y and minus 18y, and if we add those together, we get minus 34y. Okay. And now the constant, which has no variable, is just minus 24. Okay, so there's the final answer, 14y cubed plus 9y squared minus 34y minus 24. Okay, cool. Let's go to 1.3.2. So we have 3 over x squared minus 9 plus 2 times x minus 3 squared. Let's see if that's right. Okay, so let's start with this one here. So if you look at, now the trick with these questions is to see how we can simplify everything in here. So if we look at those two denominators, we can see that there's some simplifications that we can do. So if we start with this one here, we have x squared minus 9. That looks like difference of two squares, right? Because 9 is a perfect square, it's 3 squared, and x squared is obviously x squared. So we have x minus 3 x plus 3. Okay, and then on this side we have x minus 3, x minus 3. Okay, I mean, we can just leave it as x minus 3 squared, or we can do it like that. It doesn't really matter. I think it'll just be easier if we leave it as x minus 3 squared, actually. Okay, now how do we work around this here? So if you look at this, we have they don't have the common denominator, so we can't just simply add 3 plus 2 and then put some denominator there. We actually need to do some manipulation. So the way to do this is you start with the first one, right? So you start with 3 and you multiply it by the other term's denominator. Okay, so here we'll have 3 times x minus 3 squared. Okay, and then you do the same thing for the other one. So you say plus 2 and then you multiply it by x minus 3, x plus 3. Okay, and then for the denominator you just take both of these and you multiply them together. So you'll have x minus 3, now it'll be cubed, because see, we're taking this 1, multiplying it by x minus 3 squared. So you get x minus 3 cubed times x plus 3. Okay. If you look closely at the numerator, you'll see that we have a common factor. So x minus 3 is there, x minus 3 is there as well. Yeah, obviously it's squared, but that's fine. So we can factor out that there. So let's say x minus 3. And now we're factoring it out. So we'll have 3 x minus 3. Do you see how it's no more squared here? Because it needs to be multiplied there out. Okay? And then plus 2 times x plus 3. So we've now extracted that x minus 3 on each of those. Okay? Close that bracket. And then we have x minus 3 cubed x plus 3. Now if you look closely here again, you'll see that we have x minus 3 and x minus 3 here. And because we have two things that have been multiplied together in the numerator, and same thing for the denominator, we can just cancel out any common terms. So x minus 3 is common there and it's common here. So this will go from cubed to squared. Okay, so let's just neaten that up. We can get rid of this, and this will become squared now. Okay, cool. Now let's go back to the top. I'm just going to move this down so we get some space. Okay, now if we go back to the numerator here, we can just multiply out everything in the brackets there to simplify it. So we'll have 3x minus 9 plus 2x plus 6 all over x minus 3 squared x plus 3. Okay. And now we can again group like terms. So we have 3x squared plus 2x. 3x plus 2x, so we'll have 5x. We'll have 5x, and then minus 9 plus 6 gives us minus 3. Okay, and then the bottom, nothing changed, so we still have x minus 3 squared, x plus 3. Okay, and that is the final answer. Okay, let's move on to 1.3.3. So I'm just going to copy that down. 1.3.3, we have 3t minus 3 to the power of t minus 2 all over 2 times 3t minus 3 to the power of t. Okay, let's see how we can manipulate this here. So the first thing to do with questions like this is to identify ones that have these more complex exponents. Okay, so you can see there we have 2 terms in the exponent instead of 1. So let's write that first one down like normal, but then for the second one, we can now break this apart. So instead of writing 3 to the power of t minus 2, we'll have 3 to the power of t multiplied by 3 to the power of minus 2. Okay, because if you remember your exponent laws, let's say I have a to the power of m times a to the power of n. That's the same as me saying a to the power of m plus n. Okay, so if you look back here, if we have to convert this here, I have a common base of 3, and then I'm adding my exponent, so it'll be t minus 2. And if you look there, that's exactly what we have up there, so that means that's fine. Okay, let's simplify the bottom one now. So we'll, well, there isn't much to do at the bottom, although what we can notice is that we have a common term. So you can see that in each of those, we're multiplying each term by 3t. So let's factor that out. So we'll have 3t, and then we have here 2 minus 1. Okay. Let's look at the top again now. So here again, we have a common term of 3t. So let's factor that out. So we'll have 3 to the power of t, 1 minus 3 to the power minus 2. Okay. Now, how do we express 3 to the power of minus 2? Well, let's think about our other exponent laws. Let's say I have a to the power minus m, right? That's the same as me saying 1 over a to the m. Okay, so for here, I can rewrite this as 1 over 3 squared, right? Because we're taking away that negative sign. And 3 squared is the same as 9. Okay, so just to clarify, I took 3 to the minus 2. I made it 1 over 3 squared. And then that's the same as saying 1 over 9, because 3 squared is 9. Okay, and then at the bottom, we still had 3t. 2 minus 1 is just 1, so I don't even need to show that because it's the same thing. And then now we have 3 to the t on the top and the bottom, so we can get rid of that. And then we just have 1 minus 1 over 9, and that comes to 8 over 9 as the final answer if you subtract that 1 minus 1 over 9. Okay, cool. So that's basically question 1 done. Let's look at question 2 now. Okay, I think I'm just going to move this to a separate page as well.